In this lecture, we have to find out IBFS, that is initial basic feasible solution of TP, transportation problem, by row minimum method and column minimum method. Okay, and the problem is given as a company has 4 warehouses W1, W2, W3, W4 and 3 plants P1, P2, P3, and the demand of 4 warehouses are given here, that is BJ are 6, 10, 12 and 15, and the supply of 3 plants are 11, 13 and 19. Okay, these are supply and these are demand, and the corresponding transportation cost are given in the corresponding cell. To use it, row minimum method or column minimum method, any one of them, we first draw a transportation table and we write here warehouses and plants, and here we write all the capacity or supply and all the demand. Okay, now before going to the transportation table, we first check that this transportation problem is either balanced or not. Clearly, summation AI, this is 11 plus 13 plus 19, this is 43, and summation BJ is also 43, and summation BJ. Okay, so we say that transportation problem is balanced. Right, this is balanced transportation problem. Now in the new table we drawn already here, we write the cost coefficient, that is 21, 16, 25, 13 and all the cost coefficient we write in each cell but in the lower corner of right. Okay, here we write 21, here 16 and so on. Now to use row minimum method first, we first use row minimum method, and in this method we have to find out the first row, that is the first row is P1 row, and now find out the minimum cost of the first row. Minimum cost of the first row is given by 13, so we have to allocate in this cell first. Here supply is 11 and demand is 15, so minimum is 11, so we allocate here 11 unit, and clearly the supply is exhausted and demand remains 2 units. Sorry, this is 4 unit, because 15 minus 11, this is 4, and this row is cross out. Clear? Because supply exhausted. Now in the new table, that is the table only P2, P3 and all the 4 columns, we first find out the minimum cost of the first row, that is first row is P2 and the minimum cost is 14, so we have to give here allocation, and the maximum number of allocation or maximum amount of allocation is minimum of 12 and 13. This is supply, this is demand, and clearly this is 12, we put it is 12. Now this is demand fulfilled, so this column cross up, here supply 1 unit revenue. Okay, now here second row is also the first row of the new table, and here the minimum cost is 17 because this cell already gone. 17 we allocate here 1 unit because their supply is 1 unit and demand is 6 unit, so we allocate here 1 unit. Okay, and this supply exhausted, so we cross off this cell, and here demand remains 5 unit. Okay, now we reach at the position here only 1 supply and but 3 demand here, so we put the demand in the corresponding cell, and it is seen that this is 5, this is 10 and this is 4, and clearly 5 plus 10 plus 4, this is 19, so demand are fulfilled and supply are exhausted. Okay, so this is the solution table or initial solution table of row minimum method. Now we have to find out number of allocation. Number of allocation is 1, 2, 3, 4, 5, 6. So we write 6, this is equal to 3 plus 4 minus 1. This is row plus column minus 1. This is 6. So obtain initial solution. Sorry, we write it initial solution is non-degenerate basic feasible. Okay, because all the 6 allocation are positive, so we say that it is non-degenerate. And basic feasible because the number of allocating cell is 6, so it is basic, and all the allocation is greater equal to 0, so it is said to be feasible. And the obtained solution or initial basic feasible solution is, we write as x14, this is equal to 11, x21, this is equal to 1, x23, this is equal to 12, x31, this is equal to 5, x32, this is equal to 10, and x34, this is equal to 4. This is the initial basic feasible solution by row minimum method. Okay, if we apply column minimum method, this is the same as row minimum method. Here we consider the first row, and in this method we consider first the first column and find out the minimum cost of the first column, then allocate the maximum amount in this cell, and then so on as by taking the first column and minimum cell of this column. Okay, and similarly we get the solution or initial basic feasible solution of this transportation problem by column minimum method, or it is column minimum method is also said. Okay, this is two very easy and important problem or important method to solve or to find the initial basic feasible solution of a transportation problem. Thank you for watching.